Okay, so we we're struggling to get through this lesson and what we're doing today is we're graphing with shifts. So that means on this side of the page we're going to do graphing vertical translations. That's all about the letter D. Okay, and so D moves the trig graph, up or down from the x-axis. It's on the x-axis if there's no vertical shift. So what do? We look at our equation. We always start with our equation and we start with A, B, C, D. A is -3, B, now B is what's multiplied to x, 2 pi over 3. C is 0 because C will always be in parentheses with x. D is -2. So our vertical shift, if D equals -2, then our vertical shift will be down 2. Now what we can immediately do is go right to our graph and see, I'm going to highlight this graph, that we can move the midline down 2. Okay, here is our coordinate plane, x and y axis, x, y. Because we have a D of equals 2, I can immediately draw the midline down here at y equals -2, and I'm going to label it. There's my new midline. Y equals -2, and that's driven by D. Y equals D. So back up to the work of it. So amplitude is the absolute value of A, which is 3. The period is 2 pi over B, which equals 2 pi divided by, my B value is 2 pi over 3. So I have 2 pi divided by a fraction. So I have to do a little scratch work, we'll call it. We take 2 pi, put it over 1, that's the numerator. We multiply it by the flip of the denominator. And when we do that, those cancel and we get a period of 3. Which means the length of one full cycle will be 3 units. The interval is the period divided by 4, and this is just, these two things are just formulas that we always use when finding the period and the interval. So we take 3, we divide it by 4, and we can't simplify it anymore, so that's what the interval is. Now, we're going to create the x-axis, the table of x values, and then the y values. We always start our graph at C. Now in this case, C is 0. We know that the period is 3, so we add 3 to C. 0 plus 3, there we go. Now to get these x values, we can add 3/4, 3/4, 3/4. There's another neat trick, which is we just want 4 equally spaced values, right? So we can take this whole period and divide it in half, 1.5. And then we can take this and divide it in half. What's that? 0.75, or 3/4, which is what we would have added. Take this, divide it in half, what do we get? 2.25. So there's our x values. We can divide in half, or we can add the interval. Add 3/4. Add 3/4. Okay, y values. I'm going to write my pattern. So I look at my equation, a negative sign. So I remember my pattern. Interval, minimum, interval, maximum, interval. Now I have a vertical shift. So the way we want to do this is we want to write the pattern underneath, not yet this, what it would have been with no shift. It would have been 0, 0, 0. Maximum would have been add the amplitude, minimum subtract the amplitude. But we do have a vertical shift, so what do? We add D. So what we're going to do is we're going to add the D value, which is -2, to every y value, every original y value. So 0 plus -2, -2. -3 plus -2, -5. And then we get -2, 1, and -2, because if we say 3 plus -2, we get 1. Get the idea. So that's how we get our y values when we have a vertical shift. Now we're just going to plot this graph. First of all, I have to create the values, so I'm going to take these x values and place them here on the x-axis. And so I'll get 0. I'm going to go 4 spaces and say 0.75, 4 spaces 1.5, 4 spaces 2.25, 4 spaces 3. And I'm just going to label my y-axis -1, -2, -3, -4, -5. And we notice, there it is. We have a midline at y equals -2. Now we're going to graph our points. 0, -2, first point. 0.75, -5, all the way down here. 1.5, -2. 2.25, y is 1. X is 3, y is -2. So I've just taken my points and plotted them. Now I'm going to connect with the smooth curve. Whoops. There we go. Pretty good. Okay? And that's all there is to graphing with a vertical shift. Now let's we're going to move to a horizontal left-right shift. So we're going to turn over the paper. Horizontal translations are all about C. I'm just putting a big C, horizontal left and right. And so C is what moves the graph left and right. We move the graph left and right C units. Now, this is really important. Before I can do that, I have to know what C is. And in order to find horizontal shifts, you must factor out B. If we look at this equation, we see that B is inside the parentheses. And what is our standard form? Let's look at that. Y equals A sine B outside the parentheses. Then we have X minus C plus D. Unless we're in this form where B is outside the parentheses, we don't know what C is. Right now, that looks like C is -pi, but you're going to see that that's not the case. So we factor out B. And I like to do a little, just to show you how very simple this is, just think about factoring for a minute. If I have 3x minus 9, and I want to factor out 3, what do? Well, I divide each piece by 3. I put 3 over here outside the parentheses, and then I see what I have left. X minus 3. And you're saying, yes, Ms. Kraft, I know that. And it seems so simple here, but when we get into this situation where we have fractions, it feels more complicated, but it's really not. Just remember what you're doing. So what am I going to do? I'm factoring out B. Well, what is B? It's the number multiplied to x. What's multiplied to x? Well, 1/2 is multiplied to x. So I divide it from both terms. And then I write my equation. Y equals -8 cosine. I pull out the 1/2. It's outside the parentheses. What's left? 1/2 divided by 1/2 just leaves me with x. Pi divided by 1/2. Well, that's a little trickier. So I'm going to scratch work. I take the numerator and make it a fraction. I'm going to multiply it, instead, because it's division, by the flip of the denominator, and I get 2 pi. So I'm going back, x plus 2 pi. And that is my C value. What is C? C